take a look at our 5.4 lesson today. In the 5.4 lesson, we are going to compare ratios and basically unit rates. When we compare a ratio, we need to find the unit rate. Remember, unit means 1. Find the unit rate of each ratio. Then we can compare. So in example 1, it says you mix 8 tablespoons of hot sauce and 3 cups of salsa, and those are in a green bowl. But then you follow another recipe and you mix 12 tablespoons of hot sauce and 4 cups of salsa. Those go in an orange bowl, and it wants to know which mixture is hotter. Obviously, the hotter mixture is going to have more hot sauce per 1 cup of salsa. So we need to figure what the unit rate of both of those will be. So we're actually going to make 2 separate ratio tables this time. The 2 things that I'm comparing are tablespoons of hot sauce, so I'll just put hot, and cups of salsa, so I'll just write salsa. And again, we're going to make 2 ratio tables for this because we have 2 potentially different rates that we're talking about. So hot and salsa. Alright, I need to label each of these ratio tables with the difference between the 2 recipes. So I'm going to call this green because that's what's going in the green bowl, and I'm going to call this orange because that's what's going in the orange bowl. So in the green bowl, we get 8 tablespoons of hot sauce for 3 cups of salsa. In the orange bowl, we get 12 tablespoons of hot sauce for 4 cups of salsa. I want to get these down to a unit ratio. So I want to know how much hot sauce is in 1 cup of the green bowl's salsa and how much hot sauce is in 1 cup of the orange bowl's salsa, and then I'll be able to tell which one is hotter. So here I can divide by 3. When I go to do 8 divided by 3, students can use their calculator. 2.6, and that 6 is repeating, so we put a bar over it. Here, we're dividing by 4. Hopefully we don't need a calculator to do this part. 12 divided by 4 is 3. I can tell then that for 1 cup of salsa, the orange bowl uses 3 tablespoons of hot sauce, while the green bowl uses 2.6. So that means the orange mixture is hotter. So again, if I need to compare 2 different ratios, I need to find their unit ratio, their unit rate, and then make a judgment on which one is, in this case, hotter. When we come down to example 2, we are looking at a better buy problem. Better buy problems have the lower unit rate. We spend a lot of time talking about this in class. We use the example of Costco or Sam's and how when you buy things in bulk, even though you're spending more money up front to buy it in bulk, you're actually paying less per item. We went over an example with toilet paper in class and how you're spending less money per square foot of toilet paper when you buy it at those bigger bulk stores than if you buy it at a store like Kroger or Aldi's or at the dollar store. So, with that better buy idea in mind, we can look here at this picture. They have a 20-pound bag for $17.20 or a 30-pound bag for $25.20. So, again, we're going to have 2 ratio tables. The thing that's being compared is pounds of dog food to the cost. Pounds of dog food to the cost. I'm just going to draw arrows for this one so that they can tell which ratio table is going with which picture. Here we have a 20-pound bag for $17.20. And here we have a 30-pound bag for $25.20. I need to decide which unit I want to go down to the number 1. Do I want to figure out how much 1 pound costs, or how many pounds cost me $1? It makes more sense to figure out how much 1 pound costs. So the thing is always going to go down to 1, not the price. The object is going to go down to 1. So in this table, we're dividing by 20. We're dividing by 20. And on their calculator, $17.20 divided by 20 is 86 cents for 1 pound of that dog food. Over here, in the second ratio table, I'm dividing by 30, dividing by 30. So $25.20 divided by 30 is 84 cents. So now that I have this down to a unit rate, or a unit ratio, or a unit cost, or a unit price, whatever you want to call it, 1 pound is 86 cents in this bag. But here, 1 pound is 84 cents. So this is the better buy. The 30-pound bag is the better buy. This gets really confusing for students right here on this word better buy, so we really have to emphasize this. The better buy is the cheaper unit price. A lot of students want to look over here and say, well, this bag costs less, so it's the better buy. This bag does cost less money, but you get less dog food, so you're not getting as good of a deal on the dog food because you're paying 86 cents per pound. So yes, this is, we can say cheaper, we can say less expensive. But this is the better buy, because for the same dog food, I'm paying less money per pound. So the 30-pound bag is the better buy. Example 3. A hot air balloon rises 9 meters every 3 seconds. A blimp rises 7 meters every 2 seconds. Complete the ratio table for each aircraft, which rises faster. So again, when I want to compare, I'm going to need to get down to a unit rate. So I'll have one table for the hot air balloon. We're looking at meters per second. 9 meters in 3 seconds. Then we're going to look at the blimp. Meters per second, but the blimp rises 7 meters in 2 seconds. In both of these cases, I want to figure out the unit rate. How many meters does it rise in 1 second? Our second thing is always going to go down to the number 1 for a unit rate. So seconds needs to go down to the number 1. So here I'll divide by 3, divide by 3. 9 divided by 3 is 3. So the unit rate that this one rises is 3 meters in 1 second. Here I'll divide by 2. Here I'll divide by 2. 7 divided by 2 is 3.5. They can use a calculator for that if they want to. So the blimp rises 3.5 meters in 1 second. So which rises faster? The blimp rises faster. The blimp rises faster because it does go further in 1 second. I just want to show we could also have said, how long does it take this to rise 1 meter? So I could have gotten a unit rate that way. Divide by 9, divide by 9. 3 divided by 9, if they typed that into their calculator, is 0.33, and that repeats, so we'll put the bar over it. Here we would have divided by 7, divided by 7. 2 divided by 7 is 0.285. So to go 1 meter, the balloon takes 0.33 seconds, but to go 1 meter, the blimp takes 0.285 seconds. So it's another way for students to see that it's faster. So really, no matter where you put your 1 for your unit, once you get a 1 somewhere, you can still make a comparison to answer the question. In B, we're going to graph the ordered pairs from the tables that are in Part A and see what we can conclude. So if we're going to make a graph, we're going to need to have 2 axes. The study tip on the side says that when we graph speed, we place time on the horizontal axis. Our time is seconds. And we place distance on the vertical axis. Our distance is meters, so we need to make sure we label that. When we're looking at our ordered pairs, we're going to be looking at, we're not going to graph these ones with the decimals, we're just going to graph the pink ones. So we're going to look at 3 and 9 and 1 and 3 for the balloon, and then 2 and 7 and 1 and 3.5 for the blimp. So the largest number that I have to go up to in seconds is actually just 3. So for seconds, I just have to go 1, 2, 3. I can put 4 on there if we want to, but we don't need to go very high. In meters, the largest number that we had at the top was 9. So I can go up to, we'll just say 10 to make it easier. And we can even just only label the 5 and the 10 just to make it a little neater. So now we're going to graph these points. So I'm going to do 3, 9. I'm going to go to 3 on the seconds axis and 9 on the meters axis. So over to 3, up to 9, and put a dot. And then I'm going to graph 1, 3. So I'm going to go over to 1, up to 3, and that's the rate that the balloon is rising. So then I would have to make a little key over here that pink is the balloon. It'd probably be nice to grab another color. In class we would probably use a highlighter. We'll make purple in this example be the blimp. So I'm graphing 2, 7, over to 2, up to 7, and then 1, 3.5. So over to 1, up to 3, and then between 3 and 4, and connecting that way. Now, it says what can you conclude? So what they're looking for, and students don't have much experience with this yet, is looking at the slope of the line and seeing which one has a steeper slope. Now, because of the way that I've drawn this and because I'm not perfect at doing this on paper, it's harder to tell, but we know that the blimp is rising faster. This line is just barely looking steeper than this line. So what they want students to be able to do is to tell and say, we can conclude that the blimp rises faster because the line has a steeper slope. Thank you for watching this 5.4 lesson. If you're a student watching for extra credit, the secret code word is dog food. If you have any questions, please feel free to contact me.